Dear students, I have come with a new module, Computation of Pearsonian Coefficient from an SU mean. So you know that there are two methods for computing Pearsonian coefficient of correlation, that is from actual mean and from SU mean. In this module, I am going to explain two problems and I am going to explain the method for computation using SU mean. So if the actual mean is in fractions, computation is very difficult. Imagine computation using fraction values for actual mean. Taking square values, everything will be difficult. So if you use SU mean, computations can be simplified. The formula for computing R based on SU mean is R is equal to sigma dx dy minus sigma dx into sigma dy divided by n, the whole divided by root of sigma dx squared minus sigma dx squared divided by n into root of sigma dy squared minus sigma dy squared divided by n. So it's a lengthy equation, but you will remember that if you understand the logic, then it will be easy for computation. So take deviations of x series from an SU mean and denote it as dx. That is the deviations, dx. So you will remember that. Similarly, take deviations of y series from an SU mean and denote the deviations as dy. Now square dx and obtain the total sigma dx squared. Similarly, square deviations and obtain sigma dy squared. So multiply dx with dy and obtain sigma dx dy and apply the equation. Now first problem we'll see. Compute Carl Pearson's coefficient of correlation using assumed mean of x and y series. Values of x 45, 55, 56, 58, 60, 65, 68, 70, 75 and 80. Values of y 56, 50, 48, 60, 62, 64, 65, 70, 74 and 82. Deviations of x series is taken from 65 and deviations for y series is taken from 66. Now the computation is explained, that is x values are there and deviations are denoted as dx. Minus signs are there and plus signs are there. Then you have to take the square of these values, that is 400, 100, 81, 49, 25, 0, 9, 25, 100, 225. Total is 1014. Similarly, y series is there. We have taken deviations from 66 and square of these values 100, 256, 324, 36, 16, 4, 1, 16, 64 and 256. Total you will get as 1073. Now you have to multiply dx into dy. So you will get 200, 160, 162, 42, 20, 0, minus 3, 20, 80 and 240. Total is 921. Now you have to substitute the values in the equation. So you are getting 921 minus 18 into minus 29 divided by 10. N is the number of observations. The whole divided by root of 1014 minus 18 square divided by 10 into root of 1073 minus 29 square divided by 10. So you will get R is equal to plus 8818. If you interpret, we can see that this is positive correlation and it's a moderately high positive correlation because it's 0.8818. So that is why positive correlation indicates that variables are moving in the same direction. If one variable is increasing, other variable on an average is also increasing or vice versa. Then plus sign indicates that it's a relatively high positive correlation. So interpretation is important. When you are writing the answer, always you remember that you have to write interpretation along with the answer. Now the problem 2. This is a different type of problem. Find Carl Pearson's coefficient of correlation between age and playing habits of the following students. So age of the students from 15 to 20. Number of students 250, 200, 150, 120, 100 and 80. Regular players 200, 150, 90, 48, 30 and 16. This type of problems are important and usually they will ask for section C question. So one problem I thought I'll explain with this module. So how we have to calculate that? What you want to compute, the two variables are not directly defined in the question. You have to calculate that. Number of students is there. X variable is the age of students. It's there in the question. 15 to 20. Whereas number of students and number of regular players are given. Y series is the percentage of regular players. So you have to calculate the value for Y series. So the first value, if you take 200 divided by 250 into 100, that is 80%. are the regular players. Second value will be 75, then 60, 40, 30 and 20. Now we have to do the computation. X series values are there 15 to 20 and Y series values are the computed values. So that is, now we are taking deviation of X from an assumed mean. We are taking deviations from 17 and Y we are taking deviations from 40, the value 40. So dx values are there, dx square values are there. Similarly, dy values are there, dy square values are there, dx into dy values are also there. So total of dx dy is minus 195, dy square is 3725, dy total is 65 and dx square is 19 and dx total is 3. Now we have to apply the values in the equation. So when you substitute the values in the equation, we will get minus 195 minus 3 into 65 divided by 6. 6 is the number of observations. The whole divided by root of 19 minus 3 square divided by 6 into root of 3725 minus 65 square divided by 6. So you are getting R value as 0.98947. So this is very high negative correlation. Values very close to minus 1. So very high negative correlation. It indicates that variables are moving in the opposite direction. That meaning there is no relationship between age and playing habits of students. So this is what I want to explain with this module. Thank you.